Cool. Well, yeah, thanks guys for coming. We're gonna have a lot of fun. My name's Yorke from Hyperlane. We're formerly known as Abacus. If you heard of the Abacus protocol, we rebranded recently. Um, but yeah, today we're gonna be talking about some developer tools that we exposed for you guys to use during the hackathon. I know the workshop was labeled with Interchain Accounts, but we also deployed a new middleware today for like interchain queries. So we're going to cover both of those, hopefully. So yeah, first and foremost, what is Hyperlane? In case you guys aren't up to speed, Hyperlane is a developer platform that enables interchain applications. And so what that basically means is there's a smart contract API that's deployed on all of our supported chains. And you can use that API to send messages between blockchains. So you kind of enable composability between smart contracts which exist on different chains. And we have kind of like a novel security model that we employ to enable this. But I think I want to keep this talk focused on kind of like the developer tooling side of things, as opposed to the security protocol, but happy to answer questions there that you guys have at the end. So yeah, why do we care about interchain applications, and why should you be building one? So today, developers that are building dApps are faced with this choice of which chain they want to deploy on when they're going out and launching their V0. And I think what developers don't realize a lot of the time is that that choice has kind of like a lot of downstream consequences. So we listed a few here. Developer experience, the tooling that's around a specific chain might be limited to that chain's ecosystem. Each chain has some idiosyncrasies, and sometimes the tooling isn't as mature on newer chains or cheaper chains, so you might be like trading that off without realizing. And then I think this one's probably should be the highest on the list. User experience, just generally like when you're choosing which chain you're deploying on, really what you're choosing is like who is the user demographic that's actually going to be able to use your application. And are they going to be required to bridge to some chain that they're not already on, which requires them to go through some like third-party application, usually taking on a lot of like counterparty risk. We've seen a lot of bridge hacks recently. So generally, like you don't want to ask users to go through some third-party application to access your app. Then we have the platform risk. So this is kind of like once you've developed a network effect on a specific chain that you've deployed on, it becomes very hard to migrate that application or network effect to a new chain if you decide that the current chain has departed from like some maybe morals or philosophy that you want to adhere to. Maybe it's like some censorship property or something like that. It generally becomes difficult to migrate, network effects, capital, etc. And yeah, this extends to composability. If you want to kind of like reach new user demographics, which are on different chains or maybe like lower fee chains or higher security chains, etc. If your application isn't designed with cross-chain composability in mind, you kind of, when you deploy to these new chains, you end up with these like new siloed instances of your application rather than an application where all of the users of your app are benefiting from kind of like the aggregate network effects. Instead, you have these kind of like siloed networks that, in the case of like an AMM, when Uniswap goes and deploys on a new chain, it's an entirely new set of liquidity. And so you kind of have to rebuild the network effects. A lot of times you have to deploy these like artificial injections in the form of like incentives to get bootstrap the utility there initially. So yeah, there's like all these consequences. And what people are doing today to go multi-chain or go cross-chain really is not scaling well. They're like I said, deploying these incentive programs, and there's like all this mercenary capital in the ecosystem that's just like chasing these incentives, and as soon as the incentives dry up, they just leave. And so is not a really sustainable model for scaling to all of these new chain environments. However, we want our applications to support these new chain environments because like there's all these different, scalability improvements and enhancements being made, which make certain user demographics, more likely to use your application. So there's like kind of this tension between the proliferation of like these scaling solutions and new user demographics, and being able to like have an application which maintains its network effects like across all these different chains. So this is where Hyperlane comes in. Hyperlane is a network that exists between blockchains, so it's not another blockchain. You don't have to choose Hyperlane. You can just like use Hyperlane tooling to deploy everywhere. And it eliminates this choice. So today we're only on EVM chains, and so you still get this nice property of like only having to write your application logic once and kind of like deploying it everywhere in like a symmetric interface. And it's built to be this connective tissue that allows smart contracts to communicate between different chains. And so you can have like intra-app communication, whereby you have a shared state model and some sort of like state synchronization that exposes a user interface on all of these different chains, but actually is doing kind of like asynchronous state synchronization on the application side, which is like obfuscated away from the user. Or you can have inter-app kind of composability. So even just like an app that's on chain X and another app that's on chain Y, they're not natively composable because they're not in the same runtime. Hyperlane like allows you to build, the aggregator app that makes those two apps composable. And yeah, like I said, you bring your app to users on any chain. They don't have to learn a new experience. They already probably have a wallet that they prefer, a certain custody solution on a certain chain that they're comfortable with. You don't want to like enforce all of these additional like frictions to your users just to like use your application. Any friction in the initial like onboarding experience is going to massively limit your ability to like scale your audience and your customer base. So yeah, and then get rid of this platform risk. So this is a little bit out of date, but we're going to talk briefly about like the lowest level primitive that Hyperlane exposes to you guys, which is the messaging API. And then we're going to talk about interchain accounts. And then I deployed interchain queries today, so we're going to talk about that too instead of the other examples here. So the messaging API, basically there's kind of two smart contract interfaces which are necessary to be implemented when using Hyperlane. So on the sending side, you have to basically dispatch mail to an outbox on the source chain, which specifies the identifier of the destination chain that you want to send the mail to, the recipient address on that chain to receive the message, and then the message itself. And you can see here that the message is just arbitrary bytes. So we're not enforcing any specific like application message encoding on you. Really, like this is a very low-level primitive, and you can do a lot with it. And then on the receiving side, in order to receive a Hyperlane message, your contract needs to implement this interface called iMessageRecipient, and specifically this handle function, which takes in an origin chain identifier, the sender address on that chain, or from the origin chain, and then the message that was passed by the protocol. And it's important to note that I guess we need to implement this specific interface because and actually also access control this function to the Hyperlane protocol, because otherwise anyone could just spoof any sort of like cross-chain message by calling your smart contract and like pretending that it's coming from some chain when it's actually not. And that has a bunch of security implications, which again I'm like trying to stay away from, but happy to answer questions. So yeah, this is like slightly annoying that you have to deploy contracts on both sides of the message lifecycle, like the sending chain and the receiving chain, because it basically means you have to like manage an application which is deployed like on all these different chains, and it like can get kind of complicated. Again, we've built out a bunch of developer tooling to make that much easier, but I want to talk about this concept of interchain accounts, which is basically kind of like a middleware implemented on top of the messaging API that like slightly constrains the message encoding, but makes your job as a developer potentially much easier in terms of like orchestrating and deploying and managing your app across like N chains. So the messaging API that we just looked at, again, like doesn't enforce a specific encoding. It could be structured, arbitrarily. You could have like JSON in there if you wanted to. And if you want to implement like a application-specific feature, like you're transferring an asset in like an asset bridge, or you want to do a swap, or whatever it is, you have to implement that as like a specific message encoding on top of the messaging API. But if we constrain the message encoding to basically actions which can represent kind of like the entire set of actions that can be taken on like a destination chain, and we leverage some properties of the EVM, mainly like the create2 opcode. We can actually like create these accounts on remote chains that are controlled only by a smart contract on the source chain. And so this allows you to basically like have a smart contract on chain A that holds assets on chain B, or does like atomic actions on chain B. Basically the way this works is like there's a interchain account that's deterministically created from the source chain contract, and that interchain account's bytecode basically restricts any incoming function calls to the source chain contract. So if you want to make one of these like interchain account actions, you basically like relay it through the interchain accounts API from the source chain contract, and then the Hyperlane protocol will go and relay that to the destination chain interchain account, which will implements this handler that basically has access control, saying, how we saw the messaging API here, basically saying that only this origin chain and this origin sender, mainly the interchain account owner, can run this function. And so the nice property we get from this API is like, now you can only implement Hyperlane interfaces on the sending side. You don't have to worry about deploying contracts on the receiving side, because the Hyperlane protocol will go and deploy these interchain accounts for you automatically whenever you route through this API. So you can basically dispatch like ABI encoded calls to be made from your interchain account on another chain. And kind of like the middleware wraps up all of the messaging API receiving. So an example use case of this type of pattern is cross-chain governance. The way cross-chain governance works today typically is like voting happens, usually on one chain, like the hub chain, and then there's like some basically like either trusted multisig or like Oracle solution to take the results of a vote that happens on like a hub chain and actually like propagate or broadcast that result to all the destination chains to like perform the specific like governance proposal that was encoded on the source chain. However, with interchain accounts, if you have a DAO contract that dispatches governance proposals to the Interchain Accounts API on the kind of receiving chain side of things. You can basically just set the owner of contracts that you want to be controlled by a DAO on another chain to the Interchain account of that DAO. And you basically have gotten cross-chain governance for free. So there's like one example. But yeah, I think like the Interchain Accounts API has, I guess, like makes it much easier to work with the Hyperlane system. So definitely recommend you guys check it out on the docs. And then I also wanted to highlight the Interchain query system, which is like super new, deployed on testnet today. But yeah, feels like another kind of like middleware developer primitive that basically just makes it easier to work with the Hyperlane system. So I think you'll notice in the messaging API that there's no kind of like native callback support. So let's say like you wanted to go and dispatch an action to some other chain and get the result of that action, and then like return back to the calling contract and then resume execution. It's not super obvious how you would do that with this API. Maybe maybe it is obvious to you, but we've found that it's like somewhat difficult for people to understand how to implement callbacks. And so we wanted to build out this kind of like interchain query system that just lets you like read remote smart contract state on other blockchains. Just like a super simple API. You know, now that we have basically on any Hyperlane supported chain, this now becomes accessible to any smart contracts. And again, the nice property is the receiving contract, or the contract which is being queried, doesn't need to implement a Hyperlane specific interface, because we're just dispatching ABI encoded calls to be run against contracts on the remote chain. So yeah, you can basically, with this API, dispatch a sequence of function calls and provide a set of callback function selectors to actually receive those query results. So hopefully you're like familiar with how function selectors work in the EVM, but the basic idea here is like you need to provide some way on the source chain to resume execution, or kind of like recover the stack once you receive the message back from the remote chain of like, what was the value of the query on that chain. And so these function selectors basically say like, what functions should I run once my query resolves and I've gotten a return value? What functions do I need to run on the source chain to kind of like resolve that value or like consume that value? Because we don't have an async await syntax in Solidity or the EVM, but you know, something you could build with this interchain query system, which like I was toying around with like hacking this weekend, is actually like an async await syntax in Solidity that like gets transpiled down to like the interchain queries API, just as like kind of a fun demonstration that like you can have asynchronous smart contract runtimes, and it just takes a little work. So yeah, here's like a quick, or this is just the API. So yeah, it's kind of similar to the Interchain Accounts API, except instead of it just being like a sequence of calls, you also have to provide the callback. Again, this is like compatible with legacy contracts, so you can like make, let's say you're on Polygon, you can go and like make smart contract queries against like Uniswap v3. You can like go and get price data from Ethereum. Like these sorts of things like just aren't possible right now. And this is an example that I just like put together really quickly. Sorry for the like lack of syntax highlighting, but yeah, basically like this is an example of querying ENS for the owner of an address from a chain which is not Ethereum. So you can just like take the ENS interface, you can, you know, figure out what label do you want to query on the ENS registry. In this case, we don't actually have the hyperlane.eth domain. Maybe we should go buy it. But yeah, if you wanted to query the owner and the expiry of the owner of that domain, you just, ABI encode calls to the ENS registry on Ethereum, and then you use the Interchain Queries API to go and query that in an asynchronous way. You'll see that we have the resolve owner and resolve expiry selector here. So basically, these two functions will be run with the return value of what was basically queried on Ethereum. We're still kind of, at least I'm still thinking about what the right interface here is. This is a little awkward for a way to implement callbacks, but yeah, I just wanted to give a quick example. And yeah, you could imagine building some sort of so this is this requires someone to do a round trip between chains. And so let's say my contract queries some Uniswap v3 price oracle. Let's say it's USDC and ETH. I want to go get that price, and then some other contract makes the same query. Both of those queries are going to require round trips between the two networks, which kind of sucks. So another idea for the hackathon is maybe implementing a caching system with this Interchain Queries API. And ENS is especially amenable to this. That's why I picked it as an example, because there's this explicit Unix timestamp expiry attached to every kind of relevant piece of state on the ENS registry. So you could very easily build a kind of cross-chain ENS cache contract that saves not only saves round trips, but actually has atomic resolution of maybe addresses, which are popular queries. And the same can be said for other types of interchain queries. This was just the example I picked. But yeah, I think we're at the timestamp, so I wanted to give an opportunity for people to ask questions. That was probably a lot to get through. But yeah. Yes, so it will work between rollups, and what's nice is you don't have to wait the optimistic period, right? So we're kind of, all of these use cases are optimized for low latency and high security. So right now I think we're on Optimism, Arbitrum. I'm trying to remember what other rollup chains we're on. I think that might be it for now, but those are the, I guess, most in-demand ones. But yeah, it's very easy for us to expand to new EVM environments. So if there's a specific chain that we're not on, and you can check that in the docs. But if there's a specific chain that we're not on, we can definitely talk to you about expanding maybe even tomorrow or something like that. You can. That's a great question. So the way our relayer implementation works is it will only include transactions, whether they're callbacks or just cross-chain messages in general. The transaction will only be included if it's expected to not revert. And so what that means is in your callback receiver, let's say, resolve expiry or whatever, in the implementation of that function, you could have a reverting condition which says this much time must have elapsed between when I dispatched the query and when the callback is being resolved. And that's kind of how you could schedule callbacks. Yeah. Sorry, it's a little hard to hear. Yeah, so what's the security model basically of interchain queries? Yeah, great question. So so Hyperlane is an example of generalized message passing which is a generalization of asset bridging, which has been like demonstrated as like super insecure and like super shitty, and like probably shouldn't trust any of these things. So we're kind of like making what we think is like a fairly novel security trade-off. We're basically establishing a distributed set of proof of stake validators that sits between all of these blockchains. They're actually staking on the source chains instead of kind of like guaranteeing that we can prevent fraud in kind of like, let's say, the return value of one of these interchain queries. Instead, what we can do is we can guarantee that there's an economic cost to fraud, a minimum economic cost to committing fraud, associated with a message that is sent outbound from a chain where Hyperlane validators are staking. And we can do that because if those validators sign something which is not committed to by an accumulator that we have in our smart contracts, we can provide a fraud proof which basically slashes them. And so we haven't actually defined all of the economics around the system. Right now the validator set is permissioned. So to some extent you have to kind of trust the existing operators. You can check out our docs and the Discord to like both like see who the validators are, if they're like fairly reputable organizations around the space, but also you can talk to them in the Discord. But yeah, right now it's a permission set, so you do have to kind of like trust the, I guess, quorum of signers in that set. But we're hoping in basically the next month or two to transition to this like permissionless proof of stake validator set, where instead of just like social trusts or like reputational trust, we have like full economic security model, which basically like most of these other bridge systems have not really implemented effectively. So yeah, great question though. I mean, like that's kind of like the core differentiation of our protocol versus some of the other like generalized message passing protocols out there, is this like economic security model that has actual like enforceable slashing conditions in smart contracts, so you can like have strong guarantees of what the cost is to commit fraud, which is not true of basically like most other security models. Awesome, yeah, thanks guys for coming. I'll be around the venue all weekend, so if you have questions or need help with anything, we have a booth upstairs. Definitely come out.